All right, so you kind of see like that midterm up there on Canvas. So it looks like it's out of 102 points. Once it's over, I'll kind of update it. There's 100 points possible, but I'm only going to kind of grade it out of 100. So the way that it'll look when you pull it open, so there's 10 multiple choice questions. So it's kind of like treating it more like a quiz on Canvas. That's how I have it set up. Because for each of the short answer, if I try to just create an assignment, it only allows you to upload one file. And I know that's, unless you can scan things, it's not possible. A lot of you, like for homework, upload multiple pictures, which is fine. So the short answer questions, there's 5 of them, and you'll upload a file for each one, right? So there's 10 multiple choice and then 5 short answer. Now there's several parts. So like one of the short answer might have A, B, and C. If you can, try to make sure you can put all of your work on within one file for each one of those questions. Okay, is that clear? So you just only upload one file for each one of those short answers. So if you do it in Word, or if you do, write it out and take a picture, make sure that you'll only be able to upload one. If you're having issues with any file uploads or anything, just email me as soon as possible what those files are. If there's any issue, kind of getting them uploaded to Canvas. Okay, because I can see when you start and stop it, and so as long as you email me right away, I kind of take it via email as well, right? But it should work okay with those short answer questions. So once you start, you'll have like a time clock that'll be 120 minutes or 2 hours. I don't think, I probably write a very similar exam for in class. So you should have plenty of time. You'll have all your resources in front of you. So hopefully this shouldn't be too bad. And then I'm hoping to kind of get those graded. And then every single person, I've kind of been storing them, so everyone starts out at the same point, unless you kind of got to me pretty early. Should be like a mass kind of exodus of getting all your project data out over spring break, as well as kind of get these graded. Okay, so that's where we are at. And I say over spring break, like I said, I've got someone just sitting already ready to go. I'm just trying to make sure that everyone's kind of getting it around the similar time. So a lot of you, maybe even then tomorrow or Friday might get an email from me. So that'll open after class at 1 today, and you can kind of take it whenever works for you over the next, I don't know, however many days. I set it to be the end of the day Sunday, so that's what, 4.5 days. That way, if you want to get out of here a little bit early, you don't have to hang around till Friday. I'll be here and teaching my other 2 sections, so I'll be here like when class starts on Friday. I'll probably just hang around for 5 or 10 minutes. If for whatever reason you have any questions or anything like that, feel free to stop by, but don't have to be here. Hopefully, if I were me, I'd probably have the exam hopefully done before then. So let me think if there's anything else I want to say here. Any questions just related to kind of the logistics of the exam? Okay, so each one of those multiple choices with four points, and then the short answer kind of indicate how many points they're worth. They're usually, it's like they're between 10, 14, kind of they shift around a little bit depending on the question. So today we'll kind of can either work on a couple of these problems, or I can kind of come up with ones that I think might be helpful to see work through. Does anyone have like a specific problem on the practice exam or the homework, or a specific just general topic they want to see maybe covered? If not, I can pick and choose a few. So there's one that I really want to make sure we go over. And now I'm not seeing it on here. Yeah. Yeah.
You do the one where it's like 15 minus 25Q or whatever.
This guy?
Yeah.
Yeah, we'll go through. I can do another one like that. So highest price, quantity discount, single price. All right. So I'll try to answer all those questions and more. So let me see. Where's I need to stop this. I need to switch this. And then we can get going. So if we have any of these representative consumer questions, we're thinking about if I have one consumer and I'm thinking about the combination of kind of the price I could charge that representative consumer and the quantity of tickets I would sell. So generally, in the ticket market, our capacity constraint is going to be way above whatever any individual consumer would demand. So here's our demand curve. Here's our marginal revenue curve. We really think about it like our marginal cost curve is really running along the axis, right? The marginal cost of providing the seats once they're already built is essentially zero. So if we had a single price monopolist, they're going to choose the quantity where marginal cost is equal to marginal revenue. So we could think about, here's my monopolist. We would then go up to my demand curve to figure out what price they would set. Our demand equation was 150 minus 25Q, I think. So what would my marginal revenue equation be? Starts at the same point, but twice as steep, right? So I now, kind of anytime I'm given my demand equation, I automatically know my marginal revenue curve equation as well. It's just the same intercept, but twice as steep. So essentially what I want is, when does that marginal revenue equal zero? So I set this equal to zero. I rearrange things a little bit, and I think I'm getting a quantity of 3 here. Right? If I then want to know, okay, what would be the profit maximizing price for this monopolist, I then take that quantity. I want to figure out where I'm at on my demand curve. So I'll take that demand curve equation, plug in that optimal quantity of 3. And another way of writing demand is like, right, the price that I'm willing to pay, right? That's what my demand is. And so here I end up with what, 150 minus 75. So an equilibrium price, not equilibrium, sorry, monopolist price of 75. Any questions over any part of those steps? Yeah, and I'll come back to the other questions.
Yeah, where did we get the information of the quantity of 3?
Yeah, so we were given our demand equation,
right,
which then we would know our marginal revenue curve, and then we're trying to see where does that equal 0. So I set my marginal revenue equal to 0, and then solve for what quantity that would be. Any other questions on that before I keep moving here? Okay, so what would my total revenue be here? Charging a single price for every ticket. I'm selling 3 tickets, so just 75 times 3 or 225. Another question I could ask here is, do some quantity discounting, right? Or how much would they pay for the first ticket if you were just going to sell this person 1 ticket? Well, if I was just going to sell them 1 ticket, I know that they'd be willing to pay whatever point I'm at on the demand curve. How do I figure where we're at on the demand curve? I just plug in that quantity of 1, right? So here I get what? 125. So if I was just going to charge them, or sorry, just going to sell them 1 ticket, the kind of profit maximizing point, if I could identify where this person was at in the demand curve, would just be to sell them the quantity of 1, figure out where I'm at on the demand curve, 125. And then if I want to do quantity discounting, I say, okay, if I then offer discounted prices for additional tickets purchased, well, how much could I charge them for a second ticket? Because I know they won't pay $125 for the second ticket, because that'd be way above their marginal benefit, right? The marginal benefit's declining. So I try to get away with charging that same price of 125 again. Well, for that second ticket, it would be like a net loss, right? The marginal benefit of the ticket would be less than the marginal cost. Okay. So what price would I charge this person? Well, it's just a matter of plugging in that quantity into your demand curve. So I get that for that second ticket, I could charge 100, right? And then I could kind of keep going, so on and so forth. So one thing maybe I might do is then say, okay, what about the second? What about the third? Third, same kind of idea. I'd plug in 3. Well, actually, I'm already done there, right? There's the price of that third one should be 75. I could then say something like, well, how much additional revenue did I earn? Well, I earned 125, 175. So if I add those up, total revenue under this discounting model would be $75 higher than just a single price monopolist, right? And just charging the same price for every single ticket, right? And selling 3 of them. If I could sell each one at a discount, I'd start the first at 125, next at 100, next at 75, and that would actually be a little bit better off. Any questions over anything there? I think there's one thing I didn't answer that's also in that short answer problem. I'll redraw this just so we kind of get this to be a little clean. You don't necessarily have to if you've got it in front of you. So we have this demand curve, marginal revenue curve, which was twice as steep, had a quantity of 3 here for the monopolist. What if instead I could charge a block of tickets, right? And let's say even further, I could ask you, like, you know, if you wanted to sell 5 tickets, what would that, you know, how much should you sell it if you're doing a one-time fee for it? But I might also ask, well, what's the optimal, right? What would increase profits the most, right? And you would have to choose the quantity of tickets that you would sell, like how many you would sell in that block, and then what the price of that block would be. We said the one that would maximize profits would be if I could figure out the area under this demand curve. I know that the consumer, this would be consumer surplus, right? If I have a price of 0 for each ticket, right? So if I was just, how many tickets would you want? They go up to this point, and here would be the consumer surplus, right? Well, I know that they're going to be willing to pay up to that amount. So the price at which they'd be indifferent, or the highest price I could kind of get away with charging for this block of tickets, would be whatever this area is under the curve, right? Now, how many tickets? It's going to be, so if we call this like fixed fee quantity, right? It's going to be, where does that demand curve hit 0? Because weirdly enough, any point past this, you know, buying more tickets actually has a negative value, right? So we know that they're not going to keep going past this point where it hits the x-axis. Am I hearing something weird? Oh, okay. I thought it was an echo, or it was echoing weird over here. I'm like, wait, did I just? Anyways, so where would the demand curve hit the x-axis? Well, the demand curve is what? 150 minus 25Q. So we kind of think about, where does this hit 0? So it's a little bit of algebra, but we can kind of show this is what? 6. I move this over to the side, divide both by 25. So I know that the optimal block of tickets I should sell would be 6 tickets, and then the fee will be whatever that area under the demand curve is. Well, how do I find the area under the demand curve? Well, the height of my triangle, I'm going from 0 to 150. The width of my triangle, I'm going from 6 to 0, or 0 to 6, multiply by 1/2, right? If I'm looking at this correct, I think gives us a fixed fee that would maximize profits of $450 for a block of 6 tickets. Questions? So what would the advantage be of being able to sell season tickets like this? Well, if I was a single price monopolist, I had what, like 225, I already forgot. We had total revenue of 225. We're only selling 3 tickets at $75 each. Well, now if I can charge just one huge fixed fee and then have the marginal cost of attending the game after that just be 0, I could actually make $450 in profit. So double, I mean, twice as much as I did with a single price monopolist, right? Which is why teams like to sell season tickets if you know, they can find representative consumers who are willing to pay for them. Any questions on that? Let me think if there's anything else I wanted to say here. I think that should be good. Any questions for me? I think we answered all the midterm there, that specific one. Let's see if there we go. So what's the highest price? So with the single ticket, we did that. Quantity discounting, what would the price of the second ticket be? Single price monopolist, we did that. And when we did the block of tickets, kind of how you would find that quantity and what that fixed fee would be. Okay. Yeah.
So what are additional revenues?
So the additional revenue, we want to think about it here. What were we making before? $225 total. If I do a fixed fee, how much am I making from this one consumer, whatever that fixed fee is? So it would be the difference between those two. So $225, right? If I'm a single price monopolist, compared to $450 for that fixed fee.
Okay, my question was, well, where it's set in reference to the first biggest revenue.
Oh, the quantity discounting one? So you're talking about right here. So the price of the second ticket we said was $100, right? So if I'm able to do discounting. The team has said quite discount. Was the price of second ticket? How much additional revenue is generated? Oh, yeah, that one's I mean, if I'm only charging one ticket, it's essentially the additional revenue is just whatever the price of that second ticket is. On the exam, I would likely do something like not comparing it to like a single ticket, but just knowing how to find the price of different quantities. Yeah. Questions? Any questions on that problem specifically, or any other type of problem or question you have? Otherwise, I'll pick.
There was a NASCAR tournament one.
Oh, yeah, that's a good one to go over, actually. That was very good. So let's see.
Got one for it if you want.
It's all right. Find it. Okay. So we've got this set up where we've got two head-to-head drivers, right? We talked about these effort models a little bit and how much actually probably to a more in-depth degree than I'll expect you to know on the exam. So we've got first prize is $1 million, second prize is $500,000. And then suppose that they increase the prizes to 2 and 1.5 million. What do we expect to happen to the effort levels of both drivers? Okay. So we've got head-to-head drivers. We can think about they're trying to choose their optimal effort level, but effort is costly, right? So we have you could even think about it as like the increasing marginal cost to my effort. Right. What we said was, without doing any expectations, which like I said, I won't push this that far in the exam. We're just thinking about what's the additional revenue earned at whatever level of effort I put in, right? Well, if we just think about the marginal revenue, it's always going to be constant at whatever the difference is between the first and second place prize, right? So we said this is going to be the marginal revenue, right? The additional revenue earned would be, well, if I lose, I get the second place prize. But if I win, I get the first place prize. So the marginal revenue of winning is going to be the difference between those two. So in scenario one, I believe it was $1.5 million. So we're going to get the difference between the two of 500 million. The second scenario, we said the prizes were 2 and 1.5 million, but the difference in between first and second would still be exactly the same, right? Because the gap in the prize money hasn't changed at all, right? Questions? Actually, somewhat of a relevant example. What happens if I increase the gap in those prizes, right? So let's say instead of 2 and 5 or 2 and 1.5 million, I do something like 3 and 1 million. Well, now the gap in between, sorry, I'll use a different color. Now the gap in between first and second prize is going to be $2 million. Not really drawing a scale here, but so if you increase that gap in between the first and second place prize, it should predict that you get more effort from the players, right? You can think about in the wildest scenario where let's say the prizes are exactly the same. Well, there, what would my optimal level of effort be? The difference is 0. I just show up. Right? I don't care if I win or not, right? But yeah, thinking about here, if the gap in between the first and second place prize doesn't change, effort levels are exactly the same. If the gap gets higher, we kind of predict that, increasing that marginal revenue curve, predicting a higher level of effort. Okay. That's as far as we kind of push those models. Any other questions, specific questions? A specific type of problem? I know there's one that I want to make sure I go over, since you guys really didn't have to be here today and a lot of people showed up. So I think I want to make sure this is a valuable time for you guys. So one thing we said, and this is as far as I need you to kind of, you don't have to have this formula memorized. You can just remember this principle, but I'll show you the formula so you can remember. We said that the optimal kind of standard deviation, or the ideal standard deviation for a league was going to be 0.5 over, and this is supposed to be a G, the square root of the number of games, right? So we said as the number of games goes up, right? Well, the ideal standard deviation is actually going to be much lower, right? So this is the idea that, like, if I look at Major League Baseball, they've got like 162 games. I mean, we're not going to see as much variation in the data just from the simple fact that each game, each loss, or each win influences that win percentage by a lower amount. If I'm looking at football, right? One game is 1/17, right, of the overall win percentage. So there's going to be much larger swings there. So that standard deviation, when I have a higher number of games, the ideal standard deviation is going to be lower. So if I think about like one league and they go to like a smaller number of games, well, that would work in the exact opposite. That would mean number of games decreases. That would increase the ideal standard deviation, right? And I could even think about this as, well, what's going to happen to that ratio that we were using to compare across leagues? Well, as long as the actual standard deviation in wins we see, like let's assume we had 10 fewer games, but that every team had the exact same win percentage back to back. In that season that had fewer games, what's going to be true about the ratio, right? Well, we know with a fewer number of games, we'd increase the ideal standard deviation. If the win percentage of the teams haven't changed at all, just by having fewer games, we've actually decreased this ratio, right? Because our denominator is getting larger. I mean, the ratio we're getting is smaller. Ideally, what we want is to get this ratio exactly equal to 1, right? Because as you know, here's my standard deviation win percentage. It should be getting, as it gets closer to that ideal, my ratio would be getting closer to 1. So we want a ratio that's closer to 1, or the smaller the ratio represents there's less kind of variation, right? Or there's less there's more competitive balance in that league, right? We want that ratio to be closer to 1. And the way that's going to operate is through that number of games, right? Influencing that ideal standard deviation. Any questions on that? Does that make sense there? So going to, you could go in either direction, but thinking about this might be a helpful one. Okay. Any other questions? Got one idea. Okay. Let's work off the slides just for a second. Let me double check. I think that those were the two that we've covered a couple that I wanted to. Revenue, subscription, blah, 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 blah. Yeah, we'll do. Where's that? Oh, come on. We'll work on this one, right? So we've got large and small market teams, and we're told the number of wins they're both targeting. And I think here I've got, let's say, oh yeah, they're both profit maximized, right? So we can start to think about different combinations of salary minimums and salary maximums that we could use. I'm actually going to start with B because I think it's a little more interesting and maybe useful. So if they're both win maximizing, what's going to happen? So we know we've got this scenario where we're looking at the wins market. We'll assume, and this is the assumption that we'll always use in these models, is that there's the same marginal cost between the large and small market teams. We could play around with this and see that just changes the results a little bit. It just be that the directional statements will be the same, would just be kind of the gap in between wins that would change a little bit if we had increase or different marginal costs across the cities. So we're told that we've got this large market team and a small market team, and 35 and 55. Let's assume they're win maximizing. So it would be the point where the demand curve hits that marginal cost curve, right? So if they're both win maximizing, what level of salary minimums and maximums could I use? So if I wanted to set a salary maximum and a salary minimum, can I do that, or what levels would I set them at? So I'm wanting to reduce this gap, right? if I try to set a salary minimum, any point above 35, what's going to happen? Yeah, if I try to set this at the salary minimum at a level that would equate to like 40 wins, this team says, for me to spend that much on my salaries, I'm actually going to be going below the point. If I'm win maximizing, that's the point where my profits are zero. My profits become negative, and you're going to continue to have this salary minimum. I'm not going to be able to stay in the league and maybe force some of those smaller market teams out of the league. If I was going to set, so I can't set, there is no minimum I can set if my small market teams are win maximizing, right? Now, if they were profit maximizing, notice if like they were down here, well, then I could actually put a salary minimum in. So let's instead assume that they were profit maximizing, I don't know, maybe at 30 games. Now, where would I want to set my league minimum? Well, I can't set it past this point, we said, so I'd want to set it, if I could, exactly at that number of wins for that small market team that would kind of equate to having that profit level of zero, or where that demand curve hits my marginal cost curve. So if they're profit maximizing, I could have imposed a minimum, right? And I would oppose it right up to the point where we'd be at the win maximizing point for the small market teams. Okay? If I wanted a salary maximum, where would I actually set it? To improve competitive balance the most.
Where marginal revenue for the large market team is equal to the marginal cost.
Yeah, so if I set it here, that's actually the profit maximizing point for these large market teams. So if all I'm concerned with is improving competitive balance the most, what would I then keep doing? I just keep lowering it, right? Because yeah, they're going to be losing profits, but that's not my objective. My objective is to get the number of wins to be as similar as possible. Under this scenario, you would actually want to set the maximum all the way back wherever that win maximizing point was for the small market teams. So, the way that the question was written, where they're both win maximizing, there's no minimum that made sense. We would put the maximum down to be exactly where the small market teams' wins were before. Small market teams would keep winning the same number of games. Large market teams would target a lower number, and we would have improved competitive balance. Although you could argue this is a loss of quality potentially, but if we're just thinking about competitive balance as the only thing that matters, that's where we would be. Any questions on that for you? Now, if they're both profit maximizing, it wouldn't change where I want to set my league maximum, right? I would still want to push my league maximum down to wherever that win maximizing point was for small market teams. If they're profit maximizing though, then we could have imposed a minimum, and we would set the minimum at that same point as well, if we were trying to improve competitive balance the most. Questions there? We'll keep moving. Yeah.
If they were profit sharing,
Yeah.
there would be an average total revenue line, right? And then that could be a minimum for the first.
Yeah, let's think about. We'll say like I'm drawing this after the shifts, right? So let's say got our small market team, and this was their demand and marginal revenue after the league took some, right? And then we had, I don't know, something like this. They're a large market team. So this is where we're at after they've already paid in. Well, now the league will kind of pay, give them a certain amount of revenue. So each of these teams would also kind of have no, I didn't draw this. There you go. There you go. These average total revenue curves as well. Now, if I'm thinking about, I could do like a combination almost. So like, let's say the small market team is win or profit maximizing. We can think about what this would result in, right? So if they're win maximizing, right, they're actually not going to continue to be at this point. They're going to push out to the point where the average total revenue curve, right, hits my marginal cost curve. So that's where profits are zero. So once again, if my small market teams are win maximizing, what league minimum could I set? I mean, if I set it down here, they're going to be like, yeah, I'm already spending that amount of money. If I set it up here, I've driven them past the profit point. So if my small market teams or my lower quality teams are win maximizing, then I can't use a minimum. Same thing as before. It doesn't matter if I have revenue sharing. Now, if they're profit maximizing, well, I know they're going to target a number of wins down here. So what am I going to do? Well, there, I say, look, I gave you all this additional money. I want you to spend up to the point where you're using it, right? Or using all this money. So you could set a minimum right at that point where average total revenue hits marginal cost. So that would be the only difference, right? Before we set it where demand was hitting marginal cost. Okay? And then for the large market teams, it doesn't really matter that we're giving this additional money. You know, they're not going to be impacted by the minimum, but we would still want to set maximums on the back here as well. Questions on that? So I think I have something that might be helpful in one of the problems, just to kind of clarify so we can think about this a little bit. So I don't want to try to trick anyone on the exam, but I want you to be critically thinking. Let's say I've only got one type of team, no large, no small markets. And some of them are profit maximizing. Actually, we'll do wins profit. And then some of them are win maximizing, right? So I've got some of my teams targeting a higher number of wins, some of my teams targeting this lower number of wins. If I only gave revenue to the lower quality teams in my league, which teams are those going to be? The profit maximizing teams. So if I give the money to my lower quality teams, that's going to now mean they have an average total revenue curve that's different from the demand curve, right? Because they're now given this lump sum of money. So if I only give money to those lower quality teams from a revenue sharing program, what I'm going to end up with is nothing changes, right? Well, something changes. They keep targeting the same number of wins the following year or whatever, but what's going to change for these guys? Yeah, right. They're just going to pocket all that additional money. So before, I mean, it isn't exactly what it was like. Here's the additional money. Now here's the additional money, right? That's not exactly what it equates to, but visually you can kind of think about, they're just going to pocket all that additional money, increasing their profits. Okay. Now, if I gave money to the win maximizers, what would that actually do to competitive balance? So let's say I gave the money to the highest quality teams. Well, they're going to spend the additional money. If I only gave it to the high quality teams, we'll see the top quality teams in the league just get even better. And that kind of intuitively makes sense. Right? We give money to these top quality teams, we're going to drive the gap kind of in wins, right? We're going to really hurt competitive balance here, right? But this is like a thought experiment. Wouldn't see that in practice, but just kind of to think about the thought experiment. If we didn't give it to the low quality, but we gave it to the high quality. Anything else with revenue sharing that I want to do? I think we're all right with that. We went through minimums and max. Oh, got one that I think would be good to know how to do. 15 minutes. So let's do. Here's my marginal costs. Here's my demand. Here's my marginal revenue. I'm just going to be thinking about one team. This could be large. This could be small market teams. It doesn't matter. Right? So let's assume that they're currently profit maximizing and they're targeting, I don't know, 50 wins, right? So I tell you they're profit maximizing, and at that point, they're targeting 50 wins for the upcoming season. If I then say, okay, how could a luxury tax alter kind of the number of targeted wins that this team has? So if I have an effective luxury tax and I know that this team is profit maximizing, it's going to increase my marginal cost curve, right? At whatever number of wins equates to spending, $200 million or whatever the cap is, that's where I'm going to see this increase in my marginal cost curve. So an effective cap would be something like at whatever amount of money would equate to, say, 40 wins. There's then an additional, you got to pay this luxury tax. So it's kind of like this decrease in the supply curve. Just we have a weird supply curve here to horizontal. So it's kind of just makes a jump, right? Now, for every dollar I spend, I've got to spend $1 plus the additional $1 of tax or the additional $2, right? So how is that going to alter a profit maximizing team's behavior? Well, now marginal cost hits marginal revenue. They actually, with this luxury tax, would target a lower number of wins. So this is good if it's my large market team, right? Because I'm improving competitive balance with this luxury tax. I'm also having this luxury tax. I might be giving some of the money, some revenue sharing. Maybe I have win maximizing small market teams that could push them out. So luxury tax would improve competitive balance, right? Now, if it was non-effective, like let's say I set it out here, well, for the profit maximizer, right, they never spend out that far, right? They would kind of stay at the same point, right? But even if they were win maximizing, I could still use this luxury tax. So notice before, if they were win maximizing, I don't know, let's call this 70, right? Now, with the higher marginal cost of this luxury tax, they're still going to target the point at where profits are equal to 0. It's just that now that's going to be a number of wins. It's a little bit lower, right? So either way, if they're profit or win maximizing, I would want to make sure that luxury tax kind of kicks in, right? So that was the idea that if they're profit maximizing, I got to put this luxury tax at a level that it would equate to about 40 expected wins. Here, I can set it a little bit higher. I can increase that salary cap, the cap to where the luxury tax kicks in. I can set it to like the higher number of wins, like 60, and then it would still impact the win maximizing large market teams. So it kind of depends, if I've got profit or win maximizing, exactly where an effective point would be for that luxury tax. Safest bet is if I just always set it something below the profit maximizing point, I know it's always going to kick in for both types of teams, right? But if I did have just a win maximizing large market team, I could kind of get away with sending luxury tax, like even all the way up to right there, like getting a jump. Any questions on that idea? So that luxury tax has this horizontal increase in the marginal cost curve. Okay. Any other specific questions? Let me think of some other things that might be good to think about. Just some principles. So if you're kind of still studying, you don't want to take it today or take it tomorrow or something like that, I would say go back through, review those 2 homework assignments. Look at those questions. I put answer keys up to both of those. So that would be good. I think anything that we've done today or Monday, kind of looking at these different things might be good notes to have or look at and have in front of you. Everything that we've covered today, someone had asked something that I didn't think was relevant. Everything was very relevant. So the effort model stuff, the revenue sharing, the luxury tax, thinking about differences in small and large market teams, talked about the ideal kind of standard deviation a little bit. That was something that I could see maybe kind of getting missed. Salary minimums, salary maximums. We didn't go over a ton today, but we did a lot on Monday where I've got changes in the capacity or changes in the demand curve in my ticket market. So knowing how to kind of go through those, and sometimes the answer may be it depends, right? Depending on the size of the ship. We did some externality stuff. That would be good kind of to go through that stuff that we covered on Monday again as well. I don't think anything else that I haven't mentioned. One thing just in general, I might review a little bit also is some of this tax stuff. So one thing that we said was we went through class one day thinking about that municipal bonds, the demand is a little bit higher for those because they're tax-free. So kind of remembering that those municipal bonds are going to have a little bit higher of a demand for because they kind of give back a higher return on investment. Thinking about horizontal vertical equity. That horizontal equity, we were trying to tax people that are using the public good. Vertical equity, we're trying to tax people that just have a higher willingness and ability to pay. And then what else would I want to say there? Also that what was one quality we said, a specific type of good where we could generate the most revenue? The more inelastic the good, right, the more additional tax revenue we can earn, right? So that taxes, we want to tax inelastic goods more, right? If we're just trying to generate high amounts of revenue, right? So that would be some good things to kind of have in your mind going into it. That was some of the more recent stuff. We kind of did an effort model one. Monopoly questions. We went through those. I think the other thing that I would maybe we'll go through ticket market one. Just to I think it'll help. So let's say I've got my tickets. Here's my capacity. And I've got that they're currently selling at capacity, right? They're selling out their stadium. Okay. Let's say I have kind of a simultaneous change, right? Let's say that I've got, let me think what I want to do here. Decrease that. I move that out. Okay. Let's say I build a new stadium and the capacity is, and we're assuming they have monopoly kind of profit maximizing behavior here. So let's say the capacity is larger, right? So I move stadiums and I get this increase in capacity. But I'm also told at the same time, I see an increase in demand, right? Actually, no, let's do it the other way. Let's say I see a decrease in demand, right? Like, I don't know, the Bears move out to Arlington Pine and a lot of people are mad. So we get maybe a decrease in demand there, potentially. So instead of drawing them both at the same time, the best way to solve these would be draw each change individually, look at what the effect of each change would be, and then kind of think about what the total effect is. So for instance, here, if I'm already selling at capacity, moving to a larger stadium is going to do what? Well, I'm going to target a higher quantity, but I know that the price I'll charge per ticket is going to be lower. What happens to total? So I've got what? Price decrease and quantity increase. That was from my new capacity, right? If I then think about, okay, let's ignore the fact that my stadium is now larger and just think about what the effect of a demand decrease would be. Well, here, if I've got this demand decrease, so we'll call this demand 2, maybe right here, marginal revenue 2. Well, now, kind of think about, I'm no longer going to be able to sell out at capacity if I saw this reduction in demand. So I would go up here. You can kind of think about this as Q3, P3, right? So that reduction in demand, so that demand decrease led to, relative to scenario 1, right? My price would have went from price 1 to price 3. So I saw a reduction in price from that. And then I saw, well, what happened to quantity? I was selling out before, now I'm selling a fewer number of tickets. So this would have decreased my quantity, right? Now, if I was drawing this out, I'd put it on the same graph just so I wasn't shifting papers or anything. Probably better to like just do the capacity change, then figure out that, then on a draw out again, draw out the demand change. You don't have to do that. Like if I ask you to depict it, you can depict it all at once. But probably more likely, I'm just going to ask you more of this for like a multiple choice question. So you just need to know the directions. So what would the total effect be from building this new higher capacity stadium, but experiencing a little bit of backlash, loss in demand? Well, for price, I know the new price is going to be lower, right? For quantity, I can't really say. It's indeterminate, right? Because the larger capacity is going to push quantity up, but that reduction in demand is going to push quantity down, right? So knowing how to think about simultaneous changes in capacity and in demand increases or decreases, do each effect on its own, then come up with what the total effect is, whether or not they're pushing things in the right direction. Right? Questions on that? Let me think if there's anything else I want to say. Well, it's kind of related and it's somewhat in the topic, so this might be a good thing to think about. So let's say another good subject to go back and revisit might be the invariance principle, right? So let's say right now, the same player would have a different impact on different teams. So like there's a lot of NFL draft talk right now. So let's say that first pick in the draft is worth $50 million to the team currently holding it. There's another team out there and they really need a quarterback. So they'd really benefit from having that top pick, right? So we know that they'd be willing to give up a lot more money, right? Their marginal benefit or marginal revenue, additional revenue or additional benefit here is much larger. So if team A has the pick, right? Let's say that, and this isn't really as relevant in real life to this pick example, but it might be for the exam in a slightly different context. Let's say there's transaction costs. They're worth an additional 10 million, right? So I don't know, something involved in the trade, like there's compensatory picks or something like that, that has some value, right? So if I want to trade, if team A wants to trade away this draft pick to team B, there's going to be additional $10 million of incurred costs. So how much would team B be willing to pay up to in order to get that pick? Well, we know they'd pay up to $100 million, but now there's this additional transaction costs. So they'd really only be willing to give up to $90 million, right? Now, in this case, the transaction cost isn't going to be large enough to probably stop this from happening because team A says, well, look, this pick has $50 million of value to us. So if we give it up, we're losing 50 million. So we're going to need at least more than 50 million. And on top of that, if we're going to have to incur these transaction costs, team A, in order to make this trade, would need at least $60 million in value, right? So when you think about it, usually we would just be using these numbers. This would be how, team B would be willing to pay up to 100 million. Team A accepts anything over a $50 million in terms of a trade package. But when we add in those transaction costs, it's going to be narrowing that range, right? There's not going to be as many values that would kind of work on both sides. In fact, if we had really high transaction costs, let's like use the most extreme. So let's say 100 million, right? Well, there's actually, the team B would not be willing to pay anything for that, right? And it's going to break down kind of the invariance principle where if you had transaction costs high enough, team B is no longer willing to trade for that pick, even though they value it the most, right? Questions on? Yeah.
Would the transaction cost be split?
So you can think about it as whatever price is agreed upon, doesn't matter what party it comes from, you're losing, you're going to have that total loss, right? So it doesn't matter if I charge team B or team A, the compensatory pick going either direction, it doesn't matter. That value's factored in to the fact that it's going to reduce whatever the price that's agreed upon minus whatever that transaction cost. It doesn't matter where it was lost at, but it's just lost, right? So it's going to kind of close that gap that they're willing to take on either side. For the sake of this example, we can complicate it a little bit more, but for that, yeah, don't worry about where it's coming from. Just thinking about it's kind of changing those ranges. Any other questions before we get out of here? Okay. So, like I said, so you guys are older. I probably don't have to do this as much. But like, if you have any issues as you pull up the exam or your work, reach out immediately. Like, don't open it, can't upload a file, and then 2 days later, just let me know as soon as possible so I can fix if there's any type of bug or any type of issue. Or like I said, an upload problem or anything like that. Okay. Also, if you have any last minute questions, I will be in my office 2 to 4 today. I'll be there 2 to 4 tomorrow. And like I said, I'll be here when our class starts on Friday. Okay. All right. Good luck. If I don't see you, have a fun, safe spring break. I want you all back in one piece.